Okay, let's look at number 10. George, the ASB president at a local community college, is attempting to estimate the proportion of students who drive to school in order to help alleviate parking concerns each afternoon. He randomly sampled 25 students out of approximately 4,000 students that attend classes in the afternoon. From his sample, 21 students responded that they drive to school. Find the proportion of the sample that drives to school. So proportion is a decimal or a fraction or a percent. We are told that 21 out of the 25 people that he sampled said that they did drive to school. So if we change that to a decimal, since our dot plot is using decimals, this is 0.84. So 84% of the students said that they did drive to school. That shows us here that 84% is our center. And the dot plot at right was created using a simulation based on part A. So this survey occurred 100 times, which is where the 100 dots come from. Draw two lines to create an interval that captures 95% of the simulated results. So we are trying to draw two lines that capture 95% of the results, and there will be some dots that end up getting left out. So the idea behind this is that if you're given the standard deviation and you're trying to capture 95% of the results, the empirical rule tells us that if this is the mean, 95% of the data should lie within 2 standard deviations of the mean. So this represents 95% of the data. So since we're given the standard deviation, we're going to count from 0.84. We're going to count 2 of these standard deviations to the right and 2 standard deviations to the left to draw our boundary lines. So we have 0.84. We want to add 0.06 twice. And that gets us to 0.96. So we want to stop here and draw our boundary line. So that's 2 standard deviations above, but we need to also go 2 standard deviations below. So we're going to subtract 0.06 twice, and that gets us to 0.72. So this is our left boundary. And we're writing the interval that we created in part B. The low, which is 0.72, comes first, comma, and then the high, which was 0.96. All of the other dots in the dot plot are not included in the 95% interval. Calculate the estimated margin of error for the interval. Margin of error is defined as the distance from the center out to either boundary. So from 0.84 to 0.96 is 0.12. Or you could go the other way. From 0.72 to 0.84 is also 0.12. The last question is, if there are 4,000 students attending classes in the afternoon, approximately how many student parking spaces should the campus have in order to accommodate the students who drive to school? And we're given a range here between blank and blank. So in order to make a good approximation, we're going to guess between the low and the high of our interval. So 72% of 4,000 would be the minimum number of spots we think we should have, and the high is 96%. So 96% of 4,000 would be the maximum number of spots that we would expect to need. So 72% of 4,000 is 2,880 parking spots. The high, we're going to say, is 96% of 4,000, which is 3,840 parking spots.